Okay, I think we'll get started. So this is our second lab for the UART transmission. So I would very much suggest that you watch lab 2, which is UART transmission number 1. We introduced in that lab all these registers. We're going to just kind of fly through them in today's lab. So to go back and really understand how the UART is sending the signal, you'd want to watch the previous video. This is going to be a little bit more trying to show an applied setting in the laboratory, let's say. So what we're going to do is we're going to be continuously taking in an analog signal, and then periodically, based on a delay setting we put, we will convert that analog signal to an 8-bit digital signal that will be sent to the computer. And then we'll plot that. Something's wrong with my Microsoft Word and Excel, so I'm going to have to do some file movement to use Google Sheets to plot this. So a little more awkward today than what I would hope, but I think you'll get the idea that we can convert now using this device an incoming analog signal and get it into a data file that we can actually plot. The material that we'll need is the USB to UART converter, same one we used last time, but I'll show that again in case this is the first video you're watching. And then computer with Python, some kind of IDE. We're going to use very simple Thony, but certainly you could use whatever you like to program your Python in. Simple setup, kind of a realistic situation. We've got our PIC microcontroller here. We're going to set pin 4 as the UART out, like we did in the previous video. And then we're going to have now we're going to activate one of the pins not as digital but as analog, and we're going to use a sensor from the MQ family. We're going to have to use MQ-3. I'm going to use one that's already on a board that gives a nice analog output signal. So we'll use that, but could be any source of analog signal. This happens to be an alcohol sensor, so I brought in some neat alcohol from the lab, or pure alcohol from the lab, and we'll just put the sensor nearby that. We'll see the signal change, and then we'll see it both in live change, but we'll also plot those data as well. All right, let's go to the program and we'll work ourselves through this. So let me just first go to the .cam quickly, just to remind you what we're using here. This is the UART to USB to UART converter. If you go to the previous video, then I went to the Amazon site where that was only $9.99, so very good deal. Also has SPI and I2C capabilities as well. This is the MQ-3 detector, and so that's what we'll be using here. All right, let's go to our full screen here and go to our program. So configuration bits, exactly the same as we've always been doing for this series. The include file, again, exactly the same. This initial PSEC to tell the program counter where to go to begin the program. Now here's where we bring in the stuff that is going to be permanent, and that is the oscillator configuration. We're going to set this up for 4 megahertz again. You can refer to page 65 and to our first video, the one where we blink the LED, to see how that all works. These are the 4 bits that set it to 4 per page 65. We're not going to be using the latch, so we're going to clear that out completely. Now we are going to be using A to D, so the shift register that's used there is ADCON1. So if we were to use this, I did notice this ADCON1 yeah, ADCON 1 is what we need to use here. Then we will. This is going to bit 7 here, this being a 0, is going to left justify. So these are 10-bit A to Ds, so they require 2 registers to carry the full 10 bits. We're just going to look at the 8 most significant bits. So essentially we're doing an 8-bit A to D converter. And so that's what, and you can have that either such that the most significant bits are in 1 and the trailing 2 then are in another register, or you can have the 2 most significant bits in 1 and the trailing 8 in the other register. So we want to be able to grab the 8 most significant bits in a single register. So that's what's going on here. We're changing to ANCEL, and we are going to clear ANCEL A just for good measure. Then we're going to set pin 0. So this turns everything to digital input output. We're going to set pin 0. So that means that's going to change pin 0 to an analog. Now that's going to be an input. So in our tris, we have to convert that to an input. So that's going to be a 1. So this is pin 0. So we're going to use pin 0. Then pin 1, pin 2, pin 3 is always an input. Pin 4 is an output. That's the output to the UART. Okay. Now we go into the UART setup. This is exactly the same, no difference than what we did in the previous video. So I won't talk about this much, but this is that bit there. Okay, now let's go into our main loop. This part is looking for the flag to show that the T-Rex register is ready to receive the data, and it's not in the process of transmitting it. Now we go to ADCON 0 here, and we're going to just put 1. The last bit is going to be 1. This is the AD on bit. So we're going to move that into the ADCON register here. That's going to turn on the analog to digital conversion. And then okay, now what we're doing here is we're going to hit, so these are the two bits we have to change. Bit 0, which is going to enable this, and then this is going to be the go button, bit 1 here. And so what this set is doing is we're setting this to go, then this is going to skip this if clear. So once this is set, this should go right to here. But if it's not set, then this will I haven't used this notation. $ is the current line, $-1 is the line before. So this will just go to the line before and sit here until this is clear. So this will turn on, make the conversion. Once the conversion's done, that will clear. And so then this will be clear and it will skip this. Otherwise, it'll just sit in this loop until that conversion has happened. Remember the analog conversion, if you remember if you did take the course on the PIC12F1822, the analog to digital conversion takes a number of clock cycles. And so that's what's going on here. Now we are going to send this analog signal to the T-Rex. So that's what's going to happen here. So we are going to move what's happening here. This is the result, the move F, and we're going to put it, the 0 here means it's going to go to the working directory. So this is going to take the contents of the analog to digital conversion. So the conversion's been done here now, and it's going to set it into the working register. Now we're going to switch banks so that we're in the T-reg register, and we're going to move the contents of the working register into the T-reg. Now, once the T-reg is full, it's going to automatically go through the process of sending the UART. So we don't have to do any more with that. That'll send the UART. We do, however, have to change to port A, or change to bank 0, which is port A, which will get us back to bank 0. And then we will call a short delay. And the delay, I'm not going to talk about the delay here. We've used this a number of times. So this will be a short delay, and then the process just goes again. So every time we go through the loop, we're going to send one 8-bit signal to the computer. Now, I've already got this loaded onto the PIC, so let's go ahead and look at the Python program that's going to be used. And the one we're going to use here is, again, available on the GitHub site. And this is going to be very similar to the previous one, except now it's going to, let's go more slowly through this. We need some different programs. These are all built in, but the PNY put, you have to get that here with the manage packages, search for that and install that. The output here is going to be the actual raw date and time, and then the value of the A to D conversion. So it'll be a number 0 through 255 in hexadecimal. Now, the port is COM4. I'm going to check that again just to show you as well. So USB to serial COM4. So COM4, that's the port, and then the baud rate is set at 301. It's nominally 300, 301. So again, we talked a lot about the baud rate in the previous video. This part is just so that we can escape the program by hitting the escape key. Here is very much like the previous program. We're just going to get the information that's coming from the microcontroller. Now, instead of just being a single number every time, it's going to be whatever value is being pushed that was from the A to D, then got pushed into the T-reg, and then out into the computer. This will then build a CSV file with the actual raw time and date, and then the A to D value. That's what's going to happen here. Let's call this, we'll call this A to D data YouTube. CSV. All right, and so then we'll just run this. We should see data coming in. Then I'm going to take some ethanol, and we'll expose the ethanol. We'll expose the sensor to the ethanol, and we'll see the voltage change. So let's go ahead and run this. And so now I'm going to, we're getting kind of a baseline. Now we'll expose this to the, and we can see here the change in the voltage. And it's now kind of maxing out. It's been now exposed to the headspace of this vial of ethanol. So now I'm going to take this out, and it'll take a little while to clear. So as we notice this coming in, we're seeing the value decrease. And I'll just let this run a little bit longer. Then I'll hit escape, and then that will create the file. So I'll go, that seems like enough. I'll hit escape. So that should write the file. So let's go ahead and try to find that file. And it was this YouTube. Now, something's wrong with my Excel, as I mentioned earlier, so I can't just click on this and then send it to Excel. But let's go ahead and open this with Notepad. And you can see time unit, the comma separated value, time unit, and then A to C value. Now, the time unit is this big everything, the exact time from the computer. And then here we're seeing a lot of 1s here. This is the base value. And then we'll see here we expose the system to, or the sensor to the ethanol. So I'm going to, let's see if we can do some fancy footwork here. I'm going to copy this, put this in my Google Drive temp. So there it is in the temp. Now I'm going to go to an open spreadsheet and import this from there, and hopefully A to D YouTube. So this is what we just took. Insert that, import automatically. And let's see if we can plot this. So copy these two, insert chart. And there it is. So we can kind of see the very quick, it has a quick response to the alcohol, and then has a kind of a slow exponential tail off once it's been exposed to the alcohol. So you could kind of get the kinetics of this very fast and then get the kinetics of that clearing as well. So you could do some interesting things with these data. Now, nothing at all was dependent on this being the alcohol detector. So you could have had any kind of analog input signal. So a great way to capture data and then do whatever you want with those data. All right, so that's it for this video, and it kind of now makes you much more powerful in terms of interacting with the outside world. So we will move on. We'll continue with the UART in the next labs, but we'll talk about receiving information from the computer.